My name is James Kress, and I am one of the designers of EnviroPlot. EnviroPlot was developed at Oak Ridge National Laboratory and is a visualization system designed to empower researchers working with environmental monitoring data. One really powerful aspect of our system is that the resultant visualization integrates directly with Google Earth to create a very natural exploration of data. Most researchers currently have this data sitting in dozens of files on their computer, or if they're extremely lucky, in a database. However, knowing what they have without reading every single line of a file like this is extremely difficult. Thus enters EnviroPlot. EnviroPlot enables this critical exploration and allows researchers to know very quickly if they have sufficient data to proceed with the study or if they need to step back and gather more. So exploring with EnviroPlot is very easy. This exploration is designed to be integrated into the early stages of the research pipeline to let researchers understand what data they currently have available from any given year or geographic area. We feel that this system is an innovative approach to the initial data exploration problem, and if you are interested in learning more, please check out our materials at this URL. Now that we've had a quick overview of what our software is all about, we need to open up the national data overview as well as the state data overview in Google Earth. So go ahead and do that now. You'll first notice over here on the My Places pane that we have a new file tree. So first thing we're going to do is we're going to go ahead and just disable the whole file tree. We're just going to get these loaded up and then we'll go through them. So go ahead and open the next one, which is our state data overview. And once that's loaded up, go ahead and turn it off as well. If we want to search through the files that we've loaded, this is a good way to do it. We can go ahead and enter an element or item that we want to search for, and we'll go ahead and just search for the first occurrence of that, and lo and behold, we do have lead in our database here. So that's a great and easy way to search through everything that we have. The next thing to note here in Google Earth is the file structure of our data. Each of these two visualizations is relatively the same. They have our legend and our two logos, and then the main file tree here. So this one, the state overview, is divided into EPA regions. There are 10 EPA regions in the United States. If we go ahead and turn that on, we'll see that it has loaded to the 1900s. Well, that's not exactly useful for us. And so that's one thing you're going to want to watch throughout the use of this application, is that time does change up here. If we want to view all of our points, we'll go ahead and move it clear to the end of time and clear to the beginning of time, and it will go ahead and it will start loading all of our points there in the background. So we'll zoom in here and we will go over what these points actually mean. So we have quite a few different methods of visually encoding data into this visualization, and an overview of those is available here by clicking on the EPA regions. So we'll first go over the temporal aspect of our data. You'll notice that it is apparently all floating off the ground. But what does that actually mean? What that means for us is that we have holes in our data. Our database doesn't have a sample point for every element for every year dating back to the first sample. However, you'll see over here, nitrate does have the first sample. If we click on that, we'll see that in the year 1971, we had one sample for nitrate, and that was taken in one sample site. And so that's worthy to note here is clicking on a ring, which represents a single year of data, will give you in-depth information about that year. Then if you go to the top of the data tree here, click on the yellow circle at the top of nitrate, that will give you an overview of the data for all of its sample years. So the next thing we'll go over here is we will go over the sample occurrence. So I will go ahead and turn on our occurrence legend up here. And so we have a few different gradations of occurrence, and those are all defined by color. So you'll see most of them are this dark foresty type green. Well, that means that those were yearly samples, taken one sample per year on average per sample site. Next, let's go ahead and show you what the sample variance is all about. So the sample variance determines the shape. So notice none of these are very circular. Well, that's on purpose. So we go ahead and we can change our aspect of our data up here. We can look down on it, which will be easier to see what our data is shaped like. See, fluoride is almost like a diamond. So what that is indicating is actually the variance between our minimum and maximum values. So the more diamond-like our data is, the greater the variance. So you see barium is less diamond-like, so it is a less of a variance. And over here, chromium basically has absolutely no variance on that sample year. Next, let's go ahead and talk about the number of sample locations. That's important when we're talking about a database of environmental data. So we want to know how widespread are these samples per state. Is there only one sample location? Are there multiple? Well, what we've done here is we've encoded that by the x-axis, or the width of each of our points. So you'll see fluoride here gets very narrow on the y-axis, but it's rather wide on the x-axis. And so that indicates that there are more sample locations for fluoride than we would expect. See, there are 37 sample sites across the state for fluoride for this given year, which is 1997 to 1998. However, if we go over here to ozone, you'll see it's very narrow. And so what that is indicating to us is that, well, there is only one sample site and 8,000 different samples. And to do one more note on time here, you'll notice that when I double-clicked on lead, it changed the time scale to be the exact period that we have it sampled for in our database. And so this is actually very interesting. If we want to only search for a certain set of years, we can go ahead and change the time slider, and you'll notice that it actually deletes the layers that don't fall within those years.